Today we are going to discuss about these drivers. Yes, in the previous session we had talked about the components of the food system. We talked about what it comprises of. It talks about production, then the food environment, then consumer behavior, and finally health and nutritional outcomes. I did not touch upon the health and nutritional outcomes in the previous section because that is what we are already doing, as many of us are nutritionists here. But I would like the team to think a bit more about the macro level things which are happening. What is happening to the food environment, how the food is produced, procured, transported, and finally reaches the food plate. And we sort of stop there because after that happens the consumption, and after consumption happens, what happens is it gets translated into nutritional status. Today, we will just go beyond, or something which is like food systems is very cross-cutting, and there are different determinants of systems and the transformation of the food system if we are talking about. And if we want to transform, and the first question is, do we really want to transform the food systems? We all know that globally we are going to fall short of production levels keeping to keep up with the population growth, and we have to be thoughtful about making our food systems more sustainable for the generations to consume food and survive on this planet. We have to be planet friendly. We have to be not only concerned about the human health but also about the planetary health, and that is where we want to transform our food systems to a more sustainable one. But to do so, we can't just focus on the chain, the supply chain, and the food environment and all, but also the external factors which are having a very important direct or indirect impact on the food systems. And these are called the drivers of food systems. Now, in today's presentation, we are going to talk about the importance of studying these drivers of food systems. Some food for thought for you. Do we have a really nicely well-defined uh, conceptual framework for the drivers of food systems? Different people are talking about different drivers. There is a lot of, I would say, replication, and people are, dividing these drivers into different domains. And there's a lot of discussion around this. And why it is important, as I've told you, it is an important determinant of food system. So we have to start thinking and discussing about it, and understanding that we have several program peoples with us. They are wondering, why do certain things don't work? Are we actually cognizant of the factors which has an important influence on the specific activity that we are trying to do to transform the food system or tweak the food system or have specific interventions to make diets more healthier, making the food environment healthier, but somewhere it's not working? What could be the reason? And the reasons could be anything from a small policy decision which in a village, the village headman takes and says that, okay, let's improve the food environment. And yesterday only I was talking to someone and she said, like the sarpanch, who is the village headman, might decide that we are not going to sell, fried foods which are cooked in bad quality fat in our village um, market, the weekly market. And that is a very local decision which is taken by a person who is responsible for the local governance. But that is also having an impact on the food environment. Who would have thought, like, is food environment about me buying a food from the market? It also something which is like regulating my market around me, or I'm getting a subsidy, or the government is supporting me to grow my kitchen, so I'm interested, inclined to grow my own food. So there are several factors, and somewhere you can think about the socio-ecological model which we talk about in behavior change communication, wherein we see that how we have at the heart of it is the person, but then he has his family, then he has his local environment, and then he has the policy environment around it. So everything has an impact on the final food choice that we are making, and therefore the food system, the food environment, the supply chain, and the other factors have a very important bearing on what we finally eat or choose to consume. Okay, so today we are going to discuss about the biophysical and the environmental drivers. I'll pick up simple examples from these drivers and discuss with you. Innovation, technology, and infrastructural drivers, political and economic drivers, demographic drivers, and lastly, the socio-cultural drivers. So these are the points of discussion. Again, you can raise your hand, stop me in between, but Akansha, you have to keep an eye because I'm not able to see the chat list here. So you can
Yes, sure,
stop me
sure,
anytime. Yeah, stop me
sure.
anytime and let people ask questions whenever they feel. Okay. All right. So in the introduction, I would say, why is it important to study food systems drivers? That's what I was discussing so far. But we know that food systems are transitioning and transforming very rapidly in LMICs. Transforming for good? Well, we can't say that for sure, but certain bad things are definitely happening. We have abundance of foods which are poor nutritional quality, and good quality healthy foods are coming at a price. There are good quality foods available in our environment, but people are not valuing it. They are getting affected or getting influenced by the markets and the way things are advertised, promoted, are presented in a very palatable manner, palatable in the sense to our behavior change. And that is where we are seeing that our food system is rapidly transitioning. The important implication and growing challenges are with the over and undernutrition, or as we can say, the double burden of malnutrition. And this is happening at the cost of environment and social sustainability. Dynamics of food systems and their unsustainability depends on identifying the key critical drivers that affect these dynamics. What is leading to this transition? What is leading to this transformation? How can we transform it for betterment? How can we make it more sustainable? We need to understand the drivers. Understanding better about the food systems driver, that is, what they are, how they function, is one of the first steps towards supporting policymakers at the global, national, subnational, and municipality levels for designing and implementing appropriate policies and programs. So, the question which Dr. Preeti asked, like, what can we do to make sure that our intervention works, is identifying these drivers and addressing them concurrently while we are working on a specific intervention. And where is the challenge? That is, despite conceptual and theoretical advances in defining food systems and their related indicators and matrices, researchers and analysts are still struggling with the critical questions like what drives these rapid changes seen in the current food systems worldwide? What are the drivers? Is it the commercial driver? Is it the production driver? Is it the trade? Are we nutrition sensitive when we are liberalizing the trade across nations? Are we cognizant about the importance of traditional foods, importance of keeping the gene pool maintained rather than going with genetic modification? Why can't we just hold on to the numerous genetic pool that exists rather than that we are going for monocultural diet and then we are talking about genetic modifications? So these are the arguments which the agriculturalists, the public health people, the food scientists are always discussing about and have different schools of thoughts and are thinking them to make them streamline them to the overall development and sustainability. So, what are the reasons why we are not able to develop a framework, clear cut framework? There are frameworks available. I won't say it's not available. But people are thinking on several directions because drivers, after all, these are determinants. One thing is identify the determinants using some kind of a data, or you develop your proposed models and see how it works, or use sophisticated statistical methods of linking these drivers to productivity and other things. Like we look at climate change and we are developing models and other using data sciences and stuff and saying that, okay, if we produce like this is going to happen. If the climate change is happening at this rate, this is going to be the outcome, how the productivity will be affected. So we are using different sophisticated methodologies to understand different drivers, but there is a lack of clear definition, lack of consistency and clarity about what exactly a food systems driver is or is not. Perhaps the causality dimension. What is the cause and effect relationship? And that needs to be understood with well-grounded theories, well-grounded, well, good amount of data, and come up with a causal pathway. Because what is causing what? We say that climate and food systems. So climate is both the instigator and the result of, is associated with the food systems. The food systems is leading to climate change. Climate change is affecting the food system. So that particular thing is always in question. Like, how do we do a climate change mitigation versus adaptation? So I'm going to discuss about those points. Then replication and or strong cross correlations amongst drivers. As a consequence of this lack of definition, one faces a shopping list syndrome. Somebody is defining 17 drivers, somebody is defining 20 different drivers, but some of them are overlapping and replication is happening, whereby very long catalogs of potential drivers are proposed without necessary consideration of whether data exists for these drivers or whether these drivers are replicating one another. And last is lack of conceptual precision, that is, inconsistencies about how drivers are described and what characterizes their relationship with the food systems that they are expected to influence. So, for today's discussion, I would be using this. Sometimes we use operational definitions. So I'm using the HLPE food systems drivers, where I have shown you this figure previously also, where we see different kinds of drivers like biophysical and environmental drivers, like the natural capital, natural resource capital, climate change, innovation, infrastructure driver, political and economic drivers, socio-cultural drivers, and demographic drivers have influence on all the domains of food systems, be it the food supply chain, be it the food environment, of course, the consumer behavior, how people are procuring food. Finally, it is their decision. And there are several factors that affects that decision, which then gets translated into diet, nutrition, and health, but also has impacts in terms of social, economic, and environmental sustainability. Okay, and finally, this has an impact on the SDGs. So today, the points that I'm going to discuss are about climate change, technology, leadership, food prices, globalization and trade, income growth. So the last three are the demographic, the income and growth distribution, population growth and migration and urbanization. These are all the demographic drivers and the socio-cultural context. So we'll start with the climate change. And this is a simple figure which shows how the current impacts of climate change on human and natural system. So here at the center, you see the current impacts of climate change. It has impact on both humans as well as on the natural environment. On the other hand, when we were discussing about Anthropocene epoch, we know that humans have an impact on climate also and on the planet also. But if we look at this direction, so there are no arrows, it's just showing connectivity, it's just not showing causality. Okay, so if we look at the current impact on climate change, it impacts on the natural environment. What happens is warming happening. When there is warming happening, there is increase in extreme weather events. There is increase in the number of days of hot days and nights, increase in the frequency of heat waves, heavy rainfalls, a decline in spring snow cover, decline in mass of glaciers and ice sheets, and finally this thing is leading to human impact, has an impact on the humans, wherein the health is impacted. So we get to see heat strokes, the role of heat in non-communicable diseases we are seeing. But so it is not the food environment which is only leading to non-communicable diseases or sedentarism. The climate itself, there is a huge data, or there is evidence on how chronic kidney diseases are affected by heat strokes and all, how heat affects pregnancy, and during the pregnancy, if high temperatures are around, how it affects the birth outcome. And so this is what we are seeing, that the weather, the climate change is affecting our health, but it is affecting our health through our food also, by affecting our agriculture. It is also affecting the water resources. So, so the climate is impacting both the planet as well as human health. It is affecting human health directly or indirectly through the food systems. And as I said, food system itself has a role to play in impacting the climate. So if we look here, it is again the cascading effect of climate change impacts on food security and nutrition. Here is the climate change. It has a bidirectional relationship on the atmospheric composition. So because of the greenhouse gas emission, there is heat being trapped within around the earth, and which is leading to global warming. But this atmospheric composition, change in the atmospheric composition itself has a role to play in the agroecosystem. How? It is perhaps changing the nutrient composition of the food because of excess amount of carbon dioxide in the atmosphere. Some positive impact also, but a lot of negative impacts as well, which we are going to discuss. On the other hand, climate change is leading to land degradation, which is leading to presence of pests and diseases. Climate change is leading to precipitation, sea level rise, temperature, all having impact on agroecological system. And agroecological system comprises of cultivated plants, livestock, forests, aquatic species. All these are affected. And when there is extreme weather event, it is not only affecting the productive capital, but also is leading to changes in the agricultural livelihoods. Like it is affecting the lives of farmers, fisher folks, pastoralists, people who are living in the forest. And if we go up, with these changes in agroecological system, the agricultural production and post-harvest is affected. How is it affected? Because after the production, if the production is less, it will have an impact on the price. It will have an impact on the quality and the quantity. That will then have an impact on the markets and trades. And markets and trades, if they're impacted or affected, it leads to changes in the income of the farmers who are selling their produce in the markets, and the food prices are increasing, like we are talking about food price volatility. And because of that, this again has an impact on agricultural livelihoods and other livelihoods. All these lead to changes in the status of food security and nutrition. So it's a complicated thing, but to cut this long story short, climate change has both direct and indirect impact on the agro ecosystem, which then has an impact on the agricultural production and post-harvest, and which leads to changes in the market. And once there is changes in the market and production, both agriculture, that is the farmers are also affected, those who are producing the food, and the other livelihoods are also affected because the food prices go up, people's purchasing power goes down, as a result of which there is an impact on food security and nutrition. I'll stop here for a second, a while, and just ask questions. Any questions so far? Or any comments? Anything you wish to add? No? Akansha, any raised hands?
No, nothing as of now, Suparna.
Okay, I'll move. You can always post your comments in the chat box. Okay, so this is a simple narrative of climate change, agriculture, and nutrition, and how they are interconnected. Climate change affects every step of food supply chain. Effects are often negative, but some can be positive, but which are overshadowed by the negative ones and may lead to better growing conditions and increased yield at some mid to high latitude places. So this is the positive bit of it. For food production, climate change is expected to cause wet areas and seasons to become wetter, and dry areas and seasons to become drier. This will increase heat and water stress in areas already more pressured, as well as pests and diseases in the crops and livestock. And this is an example which I have cited. Now, moving on from the production to the storage, processing, and transportation. Now, if the weather is wetter or humid, then what will happen? Pathogens will grow. For example, mycotoxins and things like foods which are kept in cold storage and all. Uh, uh, the cold storage requirements and food waste from extreme weather events are going to be higher if all these things persist. As sea levels rise or increase in temperature, there will be that will make our roads and railway lines on the coasts and the travels are become difficult because of the increasing sea level rise. Not only that, increase in sea level rise also leads to salinity. So the production bit is also affected. Salinity of the salt goes up. I have colleagues from Bangladesh in this group, and they know that there are issues around high salinity of the salt, of the soil. Water salinity levels are higher, so the water are no longer potable in the coastal areas and all, and the difficulties which the communities are facing, and perhaps the problem of hypertension is something which the NIHR Global Health Center in India, Bangladesh, and Indonesia, and this course is a part of it, are actually investigating how high levels of salinity in water can lead to non-communicable diseases, especially hypertension and CVD. Okay, so yeah, that's how it is affecting our health. And temperature and precipitation changes also affect crop productivity. That is, some geographical areas will produce less while others will produce more, forcing crop production to move and transportation systems to adapt, move food from new production locations to area where it is needed. So there is a lot of exchange of food commodity will happen with these high levels of temperature and or the precipitation, high changes in temperature and precipitation. Now, what happens? So this is like immediate thing, like the production is getting affected, the transportation is getting affected, the cold storage requirement is getting affected. All the factors of the food supply chain is getting affected because of climate change. What happens to the nutritional composition? Now, the nutritional content of the global cereals, so looking at the data from years, what we are seeing is the nutritional content of the global cereal supply has declined as production has increased since 1960. So you see, the production has gone up. We can see the production on the left hand side. We are seeing the fractional dietary requirement intake per 100 gram. So for the same amount of cereals, that is per 100 gram, though the productivity has gone up, its contribution towards energy, protein, iron, and zinc has decreased. The productivity has grown up. So if you see the gray colored thing, this is going up. But if you look at the black line, which is protein, which is somewhat going down 5%, sorry, 4% decrease in the protein contribution from the same 100 grams of cereal. See, the amount has gone up, but contribution from protein has gone down. Contribution from energy has remained more or less same. Contribution from iron is 19% decrease and zinc is 5% decrease. What could be the reason? Can someone tell me, like, how does the composition change or the food composition of cereals change? Or you've heard about C3, C4 crops and all. And why does it change with the change in climate change? Change in the climatic conditions or atmospheric conditions, if I want to be more precise, like higher CO2 levels, can it lead to change in the nutritional composition? Anyone? Anyone? Any thoughts? Do you think there could be a possibility with higher CO2 levels, the composition of crops will change? Or you have heard about it? Okay, Preeti says soil quality has deteriorated. That is one. That means the productivity will go down, Preeti. But do you think that the composition of the soil leads to changes in iron, zinc, proteins, and all? Maybe trace elements and minerals are something to be we should think about because of the poor soil quality. Anything related to the CO2 in the atmosphere? The high levels of carbon dioxide that we are saying, the greenhouse gas emission. Can that lead to changes in the composition of the cereals? The answer, let me share the screen. Okay, this will go in a while.
Suparna, someone says that it affects nutrient availability.
Yes, it affects
Maybe
nutrient
because it,
availability.
uh,
Yeah, go ahead, please read it.
someone else says that maybe because it affects photosynthesis.
Very nice, you're closer. That's very good. Who has said that, the photosynthesis part?
This is Komal.
Yeah, that's a good point, Komal. And nutrient availability, in the sense, if you want to make food bioavailable, it's our gut, our system, which is responsible for making food available. But you might say that there are more inhibitors and the composition is changing, could be. But its known theory is something to do with the photosynthesis, which is a very good point. And how does climate impact nutrient content? So, when we have higher CO2 levels in the atmosphere, it definitely stimulates plant growth, but it leads to rise in CO2 levels. If you read here, leads to opening in plant shoots and the leaves shrink. So the loss of water is less. But the research suggests that as plants lose water slowly, their circulation slows down and they draw less nitrogen. So there is overall the stomata. They say that on the surface of the leaf, these are small little eyes which shrink. So the water losses are less, but as a result of water losses being less, the circulation slows down, as a result of which they draw less nitrogen. So the plant's protein contents will likely decrease with significantly higher levels of CO2, but there will be an increase in the concentration of or content of carbohydrates. So what we are seeing is currently it is 409 parts per million, but it will reach by 540 to 9, from 540 to 960 parts per million, which is projected to reach by 2100. So we are seeing a lot of carbon dioxide in the atmosphere, might lead to improvement in the carbohydrate content, but will lead to decrease in some of the circulating mineral or the mineral absorption, or zinc and proteins and iron content reduces drastically. So the impact of this is an important paper by Smith and Myers. They have done a lot of work in this. The impact of anthropogenic CO2 emission on global human nutrition. And they are saying that impact of elevated CO2 concentration on sufficiency of dietary intake of iron, zinc, and protein. And they sort of modeled per capita food availability stratified by age and gender, assuming constant diets and excluding other climatic factors on food production. And just they did this kind of a modeling exercise wherein they just elevated the level of CO2. And what did they find? That an additional 175 million people will be living in this planet who will be zinc deficient. There will be additional 120 million people to be protein deficient. And for iron, 1.4 billion women in the childbearing age and children less than 5 years will have more than 20% of them will have anemia, high prevalence of anemia, and would lose more than 4% of dietary iron, because the overall composition of the food will change because of the changing environment. That is the simple message that we want to give. And there was another study, again, a kind of a exercise which we did in understanding the zinc intake in India, both past, present, and future. And the study again showed that the increase in zinc adequacy is driven by a relatively constant zinc intake being increasingly insufficient to meet 5% growth in zinc requirement due to an aging population. We know that ours is an aging population. The life expectancy is increasing. So with the life expectancy, we would expect them to consume more zinc and have more zinc in their body for taking care of the usual wear and tear and immunity. And zinc has so many roles to play in nutrition. But reaching a 550 parts per million of CO2 by 2020 could potentially increase the prevalence of inadequate zinc intake by 4% points, corresponding to 65 million people having inadequate zinc intake. So these are some modeling exercises which are being done. but this is coherent with increased amount of CO2 and not keeping certain other things constant. So if the other things also go haywire, you can understand there is a likelihood that the composition of the food that we are eating might change with the changing food environment. As nutrition community, it becomes all the more important to be cognizant of these impact of climate change on our food plates. And this is an interesting slide on how species diversity is decreasing. And a century ago in 1903, you see so many varieties of beets, peas, radish, and all. And this is 80 years later, you see we are only, if you see from 288, we have gone down to 17 varieties of beetroots and 28 varieties of cabbage. And you see how the species diversity, the crop species richness is decreasing with time. And that is what mono agriculture, mono type of productivity, going ahead with hybrid varieties. Of course, productivity is important. We have to feed this population, but somewhere we have to be, we should recognize that maintaining the gene pool, the diversity is very important for the planet to survive long decades of survival for centuries and all. So the seasonal effect of climate change and implication on nutritional and health, well, we know that changes in rainfall results in crop failures and flooding can affect nutritional status, particularly stunting. So there is a very important paper from Robert Johnston. If you just search it, you will find how stunting shows a seasonal trend. The seasonality has an implication on the prevalence of stunting in children, and that has been shown from the global data. Increased temperature may also increase the risk of heat stroke during heat stress during pregnancy. Additionally, physical and emotional stress caused by these influences birth weight. Drought may lead to food shortage. Flooding has both short-term and long-term effect and child growth through changes in the food consumption. We know there are lean periods. There are periods when we see more of infections, more of wasting happening in children. So drought has a direct relationship with child undernutrition, drought and flooding both. The effect of climate change also have the potential to worsen the intergenerational cycle of malnutrition. Why? Because of the second point that, if there is stress during pregnancy, if it is affecting the birth weight of the child, of course, the climate change will lead to intergenerational malnutrition. But as I said, food system is both a victim as well as an instigator of climate variability and change. We all agree with that, right? The way we are producing food, is it climate friendly? Perhaps not, because we are thinking about survival, but we have to be thinking about both human and planetary survival. And that is where food systems transformation and sustainable food systems come into play. So this is a typical figure, which I've already shown you, that these are the drivers of food system on the top: climate and natural capital, globalization, income, urbanization, population, etc., has an impact on both food supply chains, food environment, personal filters such as economic, cognitive, aspirational, and situational domains, and which results in outcomes. But climate variability, including extreme events, has impact on all these specific domains, which then lead to, and we as a food supply, we are the producers, we are the consumers, and the way we are producing and consuming food is leading to greenhouse gas emission, loss of biodiversity, water footprints, which also in turn is affecting climate variability. So what can we do? We can think of climate adaptation. What is climate adaptation? It is the means of altering our behavior, our systems, our ways of life to, affect the environment in which it impacts the climate change, right? The way we impact the climate change. So that is climate adaptation, where we are changing and altering our ways of life, the way we are producing the food, we might think. And mitigation is actual reduction or avoiding further emissions and all. So these two terms we keep hearing: climate adaptation, that The harm has happened. Now let us do something to adapt to this climate change and prevent further harms and do mitigation, like change our ways of producing the food, um, and reduce or avoid the excessive emission of greenhouse gases and others to prevent further deterioration. So we keep hearing about these two terms when we are talking to the climate scientists and when we are working on food systems intervention. We need to focus on either or both. The environmental now we are looking at the other side. How does the food production affect the environment? We all know approximately 30% of all greenhouse gas emissions are from the food systems. More than 70% of the freshwater use is for agricultural purposes. And the mono diets that we are promoting, the way we are, for example, in India, we know that Punjab has always been the state producing a lot of wheat and feeding the whole country, but they are producing excessive amount of rice also. And they are given water subsidies and all to grow more and more rice to send it to the rest of India. But what are we doing at the end of the day? We are depleting the groundwater. So we are perhaps not climate sensitive and we are not producing rice sustainably. And that is the reason why and then what is happening is all the local traditional species, the local traditional millets and others, the production has gone down drastically because our policies are somewhat not climate sensitive, not environment sensitive, not nutrition sensitive. So the species richness is going down. We are losing out on our biodiversity. And if you see by 2005 or 7, the greenhouse food related greenhouse gas emissions maximum we know is from the red meat, poultry, eggs, dairy. And look how it has increased from, or it will increase from 20 to, in 50 years' time. Now comes the next. So this is all about the climate. Again, we can have a module on climate and nutrition, but the purpose is to just sensitize ourselves so that we read more. Okay, so read more about climate and think about the climate drivers of your food systems intervention that you are thinking about, and what could be the potential barrier or facilitator towards making your food systems climate sensitive, and how climate can lead to some kind of an issue with your food systems. Because I'll give you an example. When I go and talk to the farmers in the tribal areas where I work, they're saying the rain has become so erratic that our sowing season has altered. So, and if we don't sow at the right time, the productivity is getting affected. As a result of which, perhaps the farmers might use the fertilizers and synthetic fertilizers and all, and that sort of affects the soil in the long run. And even if they're not doing that, their overall productivity has come down. And if the overall productivity has come down, they're not able to sell their produce. They are not able to sustain normal food supplies at the household level. So there is more migration. There is more of crop failure. So see how it is also affecting the demography of a particular region because of the climate. So it is not only the productivity, it is all interrelated. It is all interrelated. And these drivers are also very much interrelated. So we will now move on to the next driver, which is technology and innovation. How much time do we have? Okay, we have time. So technology and innovation, well, we all know innovation is a major engine for food system transformation. It is critical to address the needs of a rapidly growing population in the context of climate change and natural resource scarcity. So building more sustainable food systems will need what? It will need better access to and use of existing technology. So we must talk about climate friendly technology now, using renewable sources of energy, like people are using solar power, air power, and all that, wind power, they're using to run their technology. So anything that you use, it should be accompanied with innovation and sustainable technology, right? So they are developing context-specific solutions adapted to local ecosystems, socio-economic and cultural conditions. Innovative technologies have the potential to sustainably produce enough nutritious food to feed the planet. It also has the potential, but it also has the potential to damage human and environmental health. So again, the other day, Vidya was asking, na, like, how do we, we are producing, food technologists are producing, we are seeing lots of packaged food in the market and all. So are we producing using technology for the benefit of the planet and humans, the packages that we are creating, the potential pollution that they can create in the environment? On the other hand, can we use technologies to actually preserve food in a way that it is natural? We use better methods to store food, to make food available all the year round without changing their nutritional composition. That is where, technology can have a role to play. Like ripening of fruits and, coating fruits with some kind of a natural coating which preserves the quality of the food, at the same time makes it available all the year round. That is technology. Novel technology does not only lie in making food fragment or creating a food or degrade it to the level of making it something which is not natural and making it palatable, in fact, hyper palatable, and feeding the population with high amount of salt, sugar, and fat. And so that kind of a sensitization is needed, and that is where technology and innovation can work wonders. Small scale production models that use organic and agroecological production techniques are often based on innovation and knowledge. And we need to tap into both scientific and traditional knowledge. So again, I'll go back to having the genetic pool, the rich genes and the natural properties of the cereal grains that we have, the rice which is drought resistant, the rice which can grow in adverse conditions. We should not lose out on those traditional traits and land races and all, and use technology to preserve it, to utilize it for human benefit. So there is an important thing, or the marriage between science and traditional knowledge is something which technology and innovation can bring. The articulation of these two types of knowledge can generate both ecosystem services and natural and social capital of the communities that serve as stewards of these landscapes. So, the social capital, the knowledge, the traditional knowledge, the indigenous knowledge of people need to be preserved. It is getting eroded at a very fast rate. It needs to be preserved. The knowledge about the land, grows, when, the edibility of plants which are there in the forest, that knowledge is going. And somewhere we need to preserve that knowledge keeping into while keeping in mind the intellectual property of these people, these indigenous people, and the social capital that we are talking about. So, respecting their knowledge, holding on to the knowledge, but superimposing it with innovation and technology so that it is preserved, it is utilized for the human benefit, not only for those land races, but for all. But we have to be careful about exploitation of that indigenous knowledge. So, due recognition needs to be given to those indigenous communities, and making the indigenous food into superfood and making a huge market and making them expensive, and not letting the people who are the owners of those food to consume it and enjoy nutrition is again another important trade-offs we might think of, and could be a kind of a commercial exploitation of the knowledge that exists within those communities. So, we have to be innovative in our thoughts, but not at the expense of others' intellectual property. So, yeah, there is a very fine line. And we know how quinoa has become a superfood. Quinoa has become a superfood, when in Latin American countries it was the natural traditional diet of the people. And now people are spending thousands and millions to procure them, grow them, and all. let it be there. Why don't you have your own superfood in the local areas and have shorter supply chain, thereby be environment friendly and grow your own food? Support the farmers who are growing that food, encourage the farmer to eat that food, and let the other people also enjoy that food, and have some kind of a price control so that there is no commercial exploitation of that food. So that is where innovation lies, that is where technology lies, and that is where the intersection of science and traditional knowledge lies. Then comes infrastructure. Again, it's an important driver of food system, right? Because foods, when grown, they need to be transported. People are growing, so the rural people are growing it, and it is going and expanding and is feeding the urban as well as the rural. So we need transportation, and that is where we need roads. We need, sh- uh, you know, uh, uh, moving the food to places from where they are grown to the places where they are processed, distributed, sold, and ultimately consumed. With globalization and trade liberalization, food moves longer distances now. Now, these longer distances also have environmental impact. But to move the food to longer distances, to make food available to everybody, infrastructure is important. And quality and access to infrastructure actually varies and often is limited to those where it should reach. So the poorest of the poor are not having access to those roads. So those who are malnourished, they're remaining malnourished, whereas people have plenty at the other end of the spectrum and are sometimes overeating also. And overeating all kinds of, because they have access to all kinds of food, right? But unfortunately, wrong foods are also penetrating to the rural markets, like Komal has pointed out. Like she has seen in the rural areas, all the wrong foods are also there. That's because they have the power of advertising, promotion, and making colorful packages. They have economies at scale. They're producing wrong foods, making it packaged, and making it aspirational for the rural community. We are not doing such social marketing for the indigenous food that the rural communities are producing and making them aware of their potential, what they're growing, and maybe making rural markets more diversified by making these foods available in the rural market. Can't we do that? That is also a real way of food systems transformation, wherein we are reducing the opportunity cost of accessing natural foods which are sustainable. But what we are doing is we are driven by market or the forces in the market who are trying to penetrate into the market and sell all kinds of wrong food with their strength of advertising. Of course, transportation access and technology and innovation in storage is also very important to reduce the perishability of the food. And that is where infrastructure becomes very important. Then comes the
Uh,
political and economic drivers.
Suparna, uh,
Yeah.
sorry to interrupt. We have 5 more minutes before the session ends. Just let me know.
Okay, fine.
Yeah,
So
thanks.
we might have to take up some of the topics later, or I would request everyone to go through the slides and come up with some discussion points. Maybe I'll pick up the interesting one. In political and economic drivers, we all know that political will leads to investment in sustainable food systems, to design, implement policies and programs to strengthen food systems, and accountability and sustained commitment comes with political will. But then, two important factors I wanted to discuss with you are the food prices and food volatility. This is an important driver. We all understand, right? People are not able to afford food because of the cost of the food. And the cost of the food is determined by several other factors. This law of in economics we often talk about is the Angel's law, where we say as the income increases, the demand for food product increases at a slower rate. So you have more money, you spend less percent of your money in food. You have less money, you spend major part of your money in food. And how much countries are spending in food? If you look, India is spending around 30%, whereas as the development goes up, the developed countries are spending much lesser on the proportion of their income on food. And the annual income spent on food, if you see, the brown dots are the big ones because there the malnutrition rates are also higher, and a large proportion of the money is also spent in food. Basically, what we are seeing is poverty, income poverty exists, and because of that, though they're spending a huge amount in food, the money spent on staples is higher as compared to money spent in diversified food. In other words, to make ends meet, they're spending a large proportion of their money in staples. And this is how the Bennett's law is saying that as income increases, households reduce food budget share of starchy staples and substitute it with fruits, vegetables, dairy, and meat. There is a very latest report which has come from Niti Aayog, and I would request my Indian colleagues to share that report with the others to have a look and look at the economist's perspective. And that's what they're saying. As India is progressing, people are spending less in staples and they are spending, and maybe that money is spent in vegetables, fruits, dairy, and meat. But I still wonder, is it the price inflation which has led to lesser, the amount of money that is spent, but how much of diverse food are they able to afford, understanding that the cost of food has gone up. If the cost of food has gone up, they might be spending the same amount, but the proportion is lesser or higher. You understand my point? If the cost is more, then you tend to spend more for the same amount of food, right? And cereals, they are not spending much, and we are thinking that they are diverting that resources to fruits, vegetables, dairy, and meat, which according to the law is true. But we have to put the price inflation factor also in that discussion. Okay. Then seasons also affect food price and volatility. In most contexts, food prices are determined Food prices are determined by market factors. They fluctuate with seasons and year, responding to supply demand interactions. Food price volatility is associated with the underlying variability. Okay, so this is how the global food prices are rising. If you can see the food price index, which is the blue one, and you can see the wheat, rice. Look at the rice, the how the percentage change has happened. But look at the highly processed foods. They are somewhat stable. Why are they stable? Because their perishability is lesser, because they have been packaged and they can be kept for a longer period of time. So the food losses, food waste is lesser. And volatility can lead to shocks and coping strategies like food crisis. If you see the food crisis, where the food is available, less amount of food is available, and how it is leading to malnutrition and illness, you can see some changes are reversible: loss of dietary diversity, discontinuation of school studies, reduction in food consumption. But there are several things which are irreversible, like people are migrating, people are slaughtering farm animals, they're selling farm animals, and consumption of seeds, collection of herbs, all these are getting affected when there is food crisis, which is leading to malnutrition. This is the last point I wanted to discuss, but we don't have time. Maybe 5 more minutes if everyone agrees, because you can always read these slides. Akansha, can we go for 5 more minutes?
Okay, yes, please go ahead.
Yeah. So, an important point is trade, and that is the trade and globalization. What is it doing to our food systems? What is a trade policy? We all know these are rules and regulations that the government put in place to govern transaction across national borders. And current trade policies are aimed to reduce barriers to trade. That is what they say. Trade liberalization so aims to increase economic growth, to increase in trade and facilitating investments. And trade liberalization policies are leading to harmonization, removal of technical barriers, reduction in tariffs, quotas, reduction in agricultural subsidies also, and equal treatment of foreign and domestic food businesses in public procurement. But what we are seeing is that whether trade openness lead to poverty reduction, the studies are showing that countries which are financially developed, which have excellent governance, which have good education about what is happening around and the educational status of its population, are able to make best use of trade openness and poverty reduction. But these are the important conditions which are needed to make use of openness of trade. If you don't have good governance, if you don't have banks and investments and openness and accountability, perhaps this is unlikely to lead to relocation of resources and to move away from less productive sector to more productive sector. These are important conditions because if you see the red dots and the red line, these are the lower group countries where they are not able to bring about much changes with this trade openness. And how does trade influence nutrition transition? This is how. So the trade governance leads to explicit trade agreement contents, then there is tariff and non-tariff barriers and stuff like that. But foreign direct investments and trade in services happen, which has an influence on agricultural production, food processing, food retail, and food advertisement. You understand? The amount of money spent by the MNCs to advertise their food is coming from those multinational companies or the foreign direct investments. And of course, there is also changes in the regulatory and policy space, as a result of which we are seeing that it has an influence on the consumer food environment. The food composition and the nutritive values are changing. Consumer food environments are changing. Pricing policy, not the policy, prices are changing. So a packaged food is much cheaper than a fresh apple because there is a lot of investment which is going. There is a lot of commercial determinant which is leading to this change in food environment. And FDI underlies many of the upstream, means way up here, interrelated dynamics in the supply, distribution, marketing, and sale of highly processed foods. So I will stop here and I would like you to go through these slides, and these are very self-explanatory slides on population growth, how population growth pressurizes food systems, fine, and how population growth puts a demand on the food system for intensification of agriculture, which has a dire impact on environment, and how urbanization has an effect on food system, and the rural urban linkage between how urbanization can actually lead to good food systems transformation by creating a demand and generating livelihood for rural population. So these are very interesting conceptual frameworks which you can have a look. I have put references under each slide. And lastly, I have spoken about the socio-cultural drivers. And again, this slide is quite self-explanatory.